So today we are going to discuss a transformer sizing and how to do it right. This is a basic skill required for every design engineer. Irrespective of any industry, you need this skill. So let's move on. We will discuss following contents in this webinar. We'll see the introduction, what is the overview of transformer sizing and selection, what is the input required for this activity, voltage level, electrical load list, how to prepare the electrical load list, codes and standards followed for this activity, what are the cooling types for the transformer, how to select the MV rating and impedance, how to decide the design margin and future growth for the transformer sizing, what are the tape changer type, how to verify your calculation, is it right or not. Then we will see the summary. Then we will see the career path and job opportunities for the electrical design engineers, what are the skills required this career path. Now you can see a typical single line diagram from generating station to the end customer. In between, you can see the different transformers of different voltage level. As you all know, as electrical engineer, that transformer are required to step up and step down the voltages. On the generating part, generally the power generation on 11 kV or 6.6 kV side, and after that, if you want to transfer the power for long distance and high power, then you have to step up the voltage to minimize the losses. So generally, we preferred for long distance, like from one city to another city, go with the 132 kV voltage to 20 or 400 kV. We can go with the less voltage also, like 66 kV, but the current rating will be very high. So the equipment size too big and difficult to handle. So generally for the long distances and high power transfer, we use a 132 kV. Once you receive the power in your city, now you need to transfer the power to the various part of the plant or the city. So you will use a voltage level like 33 kV or 66 kV, because you don't want to be transfer the power with the 132 kV voltage all over the city. It is dangerous. Now for further interior of the city or the plant, you will use the high voltage like 11 kV. It's a safe, and some industrial consumers also need this power directly. And at the domestic level or the equipment level, for low voltage, you need a 415 volt supply, a three-phase supply generally used in India. So like that, we use the step up and step down method to get the power supply from power plants to our consumer level. For the voltage level, you can refer the IEC 60038, where you can find the standard voltage levels used all over the world. So transformer is a critical device. But why? Because you can see the transformer is the first equipment that connects the external system to the internal system. Like if you are having a plant, any plant, and you're getting supply from the power grid. So the transformer is the first equipment that getting the power supply from the grid. So basically the transformer handling all the disturbances from inside the system and outside the system. And transformer also the device which try to handle the voltage variation due to overload, underload, so your power system will not be disturbed. So transformer sizing is an important activity. When you sizing the transformer, you are not sizing only for the present loads. You have to keep the business growth in the mind, what will be the future loads. So you need to keep in that thing in mind. Otherwise, you have to change the size of transformer. After some year, if you want to increase your size of the plant, you want to increase the production capacity, you want to install more motors, then you will be in a problem, and you have to install a new transformer. Second thing, transformer is a big device. The manufacturing of transformer takes time. So engineer has to decide the transformer in the initial stage of the project with considering some margins. So it's a important activity. Third, in any case, if your selection goes wrong, and if you want to change the transformer, so it's a costly affair. Why? Because you are not changing only the transformer, but you have to change the associated equipments like cables connecting the transformer from primary side, secondary side, and the switch gear to which the transformer is supplying the power, because all depends on the current rating of the transformer. So that's why engineer has to keep these things in mind while sizing the transformer. Okay, so now you can see a single line specification like 11 kV by 0.433 kV, 1250 kVA, 6% ONA and OCTC. What is this? This is the single line specification to purchase the transformer. The single line covers the 90% requirement to purchase the transformer. First thing is a voltage level, 11 kV by 433 kV. This is the primary and secondary voltage. Second thing is a 1250 kVA. It is the kVA rating. 6% is the impedance. ONAN is a cooling type, and OCTC is the off-circuit tape changer. Is a tape changer. I believe as electrical engineering students or a professional, you know You have read all these things in college, so we will discuss further. So now in the further slide, we'll learn how to decide these things for your transformer. But before going further, you need to check what codes and standard has to be followed. In engineering business, everything is governed by the codes and standards to make the engineering standards all over the world. If your project's in India, then you have to follow the IS codes. For transformer, IS 2026 is the governing code. IEC 60076 is a European code, and this is the most widely used code in the world. Third is the National Electric Code. It's an American code, generally followed in the North American countries. Apart from that, you have to check any local codes also. Like if you're doing a project in Vietnam with the European codes, it's okay. But before doing the final sizing, you have to check any local code requirement. If anything is there, it supersedes all the requirements. So remember these things always. Okay, now we are on the voltage level. How to check the primary voltage? As we discussed, like primary voltage, generally on the primary voltage, you don't have much control because you are getting a power supply from the power grid or from the another power plant. So generally you don't have much control on that part. But if you have a choice, then decide basis on your distance, from how much distance you are getting power and what power is transferring, then accordingly you have to select your primary voltage level. Secondary voltage. So secondary voltage depends on what are the equipments in your plant. Like if I talk about India, in India, motors up to 160 kilowatt are fed from the low voltage, which is 415 volt. And motors greater than 160 kilowatt are fed from the 6.6 kV or 11 kV. Accordingly, you have to design the power system in your plant, and you have to select the transformer in your plant. Like if you have both motors, then you need a two transformer which giving the supply of 6.6 kV and ultimately 415 volt. But one thing you have to remember, this is a very important thing to remember. Whenever you mention the secondary voltage for the manufacturer, you always mention the no load voltage. See how in India the 415 volt is a standard voltage for low voltage power system. But in the switch gear, if you want a 415 volt on your switch gear, then transformer secondary voltage should be higher than that, because in between there is cable and there will be voltage drop in the cable. So generally we have a no load voltage on transformer secondary as 433 volt and the load voltage will be 415 volt. So we have a sufficient margin to have some drop in the cables. So always keep this thing in mind whenever you decide the voltage level and give it to the manufacturer. So now this is the most important thing to decide the transformer. Electrical load list. What is electrical load list? Electrical load list is a dynamic document where electrical engineer lists all the loads which require power supply to operate. So you have one document where you list all the equipment which needs power supply. But why I'm calling it dynamic document? I'm calling it a dynamic document because these inputs keep changing throughout the project. Because initially you have a very tentative loads, but you calculate, you get the inputs from manufacturers, motor vendors, then you have the final inputs. That's why these documents keep changing throughout the project cycle. That's why I'm calling it a dynamic document. It is the very first document required to start the electrical activities on the project and required interface with all the concerned disciplines. Focus on this part, the required interface with all the concerned disciplines. As an electrical engineer, you will get the input from the various disciplines. You are not going to calculate everything. Lots of equipment are not controlled by you. Like other disciplines are handling that equipment and you get the input from the other disciplines. Let's see in next slide. So this is the document format. This document format will give you an idea of how the actual load list looks like. You can see in the first two columns, their tag number, and the equipment description. It's a name only. After that, you have load category, feeder type, load factor, rated load, power factor, efficiency, and the intermittent and standby calculation. I will explain in the next slide all these things, but this gives you an idea of how the actual electrical loads and how it looks. So your first responsibility is to get all the equipment which needs power in your project, like motors. What are the motors, heater, IT loads? I'm calling it a process load, because process is the industry you are working. Like if you are doing a project for building, then HVAC and lighting are the main loads. If you are doing in some manufacturing plant, then motor, heater are the main load. They call it process loads. Apart from neck lighting, UPS, all are the common loads. And next thing is the package loads. These package loads are the very important load because this is generally a manufacturer's package. Like if you are purchasing a compressor from some manufacturer of 500 kilowatt rating, so you are ordering a compressor manufacturer a 500 kilowatt compressor. So you have to consider load. But compressor is not only a single motor. Small motors are coming with compressor for the cooling, for the heating, some other purposes, which you don't know in the initial. So you need to coordinate with the manufacturer and get all the input. So that's why this is an important part. You can afford to miss these things. Otherwise, on the last stage, you will have a problem in the transformer sizing. In the starting of the project, use past data for the loads for which information is not available. If something you know this equipment is going to come in your project, but you don't have data, so you can refer a past project or you can talk to manufacturer to getting some data. So you can consider that in your load list, because at this stage your effort should be on getting as maximum as data so that you can size the transformer properly. Next is the load category. You have listed all the loads in your load list, but you have to categorize them. This is a very important part. First category is a vital load. You can see in the bracket, it's a safety factor. Some loads are very important for safely operation of the plant and especially the safety shutdown of the system, like fire pump, UPS, emergency lighting. If there is fire in the plant, fire pump should run anyway and the plant should be shut down safely. And like if it happen in the night, the person should be able to evacuate from the plant. So they need a lighting for that purpose. So these are the loads which are important for the safety of the plant. Next is the essential load. You can see the economic factor. Some loads are necessary for the economic purpose. Like in the night, you need a security lighting. You need to operate transfer pumps because your plant is running and suddenly shutdown is happened. But your product is already ready. So you want to transfer their product to a safe place so you will not lose money. So that's why some products are necessary from the economic point of view. Third category is the non-essential loads. Some loads which are neither falls in the vital load category nor in the essential load category. So we call them a non-essential loads like lighting, normal lighting and socket, etc. This classification will help us to calculate the sizing of UPS and DGs. So from the vital loads, you know that this equipment need to be operated in any way, so you will feed them from UPS, and generally the essential loads are fed from the DL generator. So in the way, this load list help you to calculate the size of UPS and DG also. Diversity factor of loads. What is the diversity factor? In the load, in the power plant, you have lots of equipment, but all are not running continuously. Some may be required once in a week, once in a month. So you will not consider everything on full load in the transformer. Otherwise, your transformer will be oversized. So for optimizing of the transformer sizing, we use the diversity factor. So there are three categories for this. First is the continuous load. Loads which operate continually in the plant. For such load, 100 diversity factor shall be considered. So it means we will consider it a full load for these loads. Next is intermittent loads. Some loads which operate for a few minutes and only one day. For such load, 50% diversity factor shall be considered. For example, in your room, you have a 4-5 sockets, but you are using only 1 or 2 sockets at a time. So we are not going to put full load for every socket. We will use a 50% diversity factor. This means we will consider only half load for such equipment. Third is standby load. Some loads in the plant are very important. We cannot afford to shut down of that plant. That equipment. So what we do, we keep a spare of this equipment, and once the main equipment is fails, then we start the another equipment. Like we have a transfer pump A and B. If transfer pump A fails, then transfer pump B starts automatically. So you will not lose the production. But at a time, only one equipment will run. So we will consider only 10% or 0% diversity factor for such loads. Fourth is dead loads. Some loads which are operate only in the case of partial or full plant is shut down. For such load, you don't need to consider in the electrical load list. You will list them for the feeder purpose, but you will not consider them in the load list. For example, like welding sockets and fire pumps are dead loads. Fire pump will only operate in the case of fire, and in the case of fire, obviously the other loads will shut down. And same as the welding socket. Welding will happen in the plant only when the plant is full or partially shut down. So it will not give burden on the transformer. So you don't need to consider this dead loads on the transformer. Otherwise, transformer will be very oversized. Next is the load factor. Load factor is very important thing. Like we are sizing a pump for transfer the liquid from one place to another. So from our calculation, the required power is coming 32 kilowatt. But in the market, 32 kilowatt motor is not available. In the market, the motor is standard rating like 30 kilowatt and 37 kilowatt. So for 32 kilowatt power requirement, you have to consider 37 kilowatt power motor rating. But actually the power will consume only 32 kilowatt. So what you will do, you will calculate the load factor. What is the load factor for this motor? And you apply the load factor in the load list, and accordingly you have calculated the power required by the motor. So that's why all load calculations shall be done on the actual load of the motor, not on the rated load of the equipment. This we do to prevent the oversizing of the transformer. So now we have calculated all the loads. So we will calculate the two attributes like maximum normal running plant load and peak load. Maximum normal running plant load is a sum of all the continuous load and intermittent loads, and peak load is the sum of continuous loads plus intermittent loads and the standby loads. It depends on the what diversity factor you have considered. Generally 100% for the continuous load, 50% for the intermittent loads, and 0% for the standby loads. Sometimes we consider 30% for intermittent load and 10% for standby loads. It depends on the loads have to supply in the plant. So this is the look of the load list, how it looks like final shape. You can see we have listed all the loads, and here you can, in the red block, you can see we have calculated maximum normal running plant load and the peak load, sum of continuous, intermittent and standby loads. So this is the how the total load of the plant we know. But this is not all. Now we have to consider some other factors. Next, this is the design margin and future margin. When we start preparing the load list, we consider some 10% design margin, because we know during the preparation, during the engineering, some loads may change, some calculation may change. So we need to keep the cushion for this change. So generally we consider 10% design margin. And the future margin, obviously the plant we are building, the system we are sizing may increase after some time. AC will increase, maybe in the building someone will put more AC than calculation, and they may be planning to add one more story. So accordingly we will keep the future margin. If anything is not specified by the client or the customer, then at least you can have a 10% future space capacity to be considered from the transformer, apart from the total present load. So next is the transformer loading. We don't want to load our transformer fully. Generally, the transformer efficiency is on 80 to 90%. So it is a normal practice in the industry to load the transformer only 80 to 90%, so that you will operate on the maximum efficiency. So what will be the final transformer load? Or what is the peak demand? What are the future margin? And what are the losses? So you will calculate this load, and you will select the transformer rating, but need to check that your transformers should not be fully loaded. For example, if you have a final load of 1000 kVA and a 90% loading is allowed, so you have to select the 1250 kV transformer. You cannot go with 1000 kV transformer because 100% loading is not allowed. So you will go with the 1250 kVA transformer, so that your transformer is well within the limits. Now you have to check what are the transformer rating available in the market. This is all rating, all standardized all over the world, and you will get the transformer rating only in between these limits. Like you can see, the rating start from the 16 kVA to 25, 6300, 200, 500, 1250, 1600 and 2000. And after that, in multiples of 10, you can get the transformer rating. This will all specify in the codes and standard for the purpose of standardization all over the world. Now you can see standard table from IEC 60076 for the selection of impedance. You can see in the first column, the rated power is given for some rating, like say up to 630 kVA, the 4% impedance is allowed. Up to 631 to 1250 kVA, 5% impedance is allowed. So these impedances are standardized by the codes and standard, and all the manufacturer has to follow. Only plus minus 10% variation is allowed by the codes And this is also all over standardized. The impedance is the internal voltage drop. But there is an MV rating limitation depend on the voltage level. Like you can see, a 25, if your transformer is 25 for the 6.6 kV switchboard, you cannot go beyond the 25 MVA rating. For 3.3 kV switchboard, you cannot go beyond the 12.5 MVA rating. And for the LV switchboard, like for 415 volt in India, you cannot go beyond 2000 kV rating. This is because the fault current supplied by the transformer, because transformer is connected from the grid power plant. So if fault happened in your system, then all the generator will supply the fault current to your system. So what is the fault current capacity of your system? Like if you talk about LV switchboard for 415 volt in India, 50 kiloampere is the general capacity available by all the manufacturer. So if you go beyond the 2000 kVA, it will be more than that, and your LV switchboard will not withstand this fault rating. So nowadays, 2500 kVA is also available, but very few customers are allowing to go beyond 2000 kVA. So that's why you have to keep in this mind what are the MVA limitation on the particular voltage. Now we will see the cooling type. I'm sure you have seen this nomenclature before also. What are the first two letters? Like ONAN is a cooling medium inside tank. ON means oil natural. Tank have a winding and they have a oil for cooling the winding. And next two letters like AN is the cooling medium outside tank. AN means air natural. So outside air will cool the transformer body, and then it cool the oil and then winding. So this is the full form of the nomenclature. Oil natural, AN is air natural, OF is oil force. Sometimes if transformer is too big, then we have to use the pump, give force to the oil, so it will travel in the body of transformer and gets cooled down. AF is an air force, so we install the fans outside the body of the transformer, so it gets cooled by the fans. Sometimes we have to use water force, but generally it's for big ratings. So, but it force cooling method increase the transformer rating also. But generally the ONN is the most commonly used transformer in the industry. So mainly the two type of transformer we use in the industry. You have seen the oil cooled type. So oil is the main cooling medium in this transformer, and it is most preferred in the industry because due to high efficiency, low cost, and a low operating cost also. Noise is very low. Now wide range. The wide range means the MV rating is very high. We can use in this oil cooled type transformer. So that's why it's very preferred. We have another transformer which is called dry type transformer, and its cooling is AN because inside the tank is only air and outside the tank is air. So it's a air natural and air natural. So generally we use this transformer where fire risk must be minimized. Like in buildings, if we have a space limitation and we are putting transformer inside the building in the basement, so we will go with the dry type transformer because it's a less risk. Or offshore platform. Offshore platform means sometime like in the Bombay High, we have oil extraction units. So it's a risky place. So there we are using a dry type transformer, and mostly lighting transformer in the plant are dry type because generally keep them inside the substation building. So for safety purpose, it's good. So now next then tape changer type. Tape changer is a device which allows transformer to adjust the voltage within the limits, generally within plus minus 5% to adjust the output voltage, because we don't want to shut down our system due to small variation of the voltage. So tape changer can accommodate this small variations. There are two types of tape changers. Like one is off-load tape changer. We call it no-load tape changer also. This is a device for changing the voltage ratio of the transformer only after the transformer has been isolated from the high voltage and the low voltage sources. So it will operate only when the system is shut down. Next is the on-load tape changer. Sometimes we cannot afford to shut down the system for changing the voltage level. So we use the on-load tape changer. But it is a very complicated system, so generally used only for some critical purpose only or critical plants. So off-load tape changer is very common to use in the industry. So now you have selected everything. You have decided your kV rating, MV rating, impedance, everything. But you need to verify the size before giving the order to manufacturer. Because as I said earlier, you cannot afford to change the size on the later stage. But how to change? So you can do with the manual calculation also, but nowadays we use the ETAP software. ETAP is an electrical transient analysis program, which is very widely used software in the industry. So we have to run these modules in the ETAP, and I think you have heard about this study. First, the load flow study. Load flow study is used for the normal power flow in your system. Like in the normal case, the voltage currents are on the limits. We will simulate the complete single line diagram and the ETAP, and we will run the load flow study, and we will see what are the voltage levels on the switchgear or on the motor. And generally, the voltage should be allowed to be within plus minus 10%. If it is in that limit, then load flow study is okay. Next is the motor starting study. This is the very important study for the transformer size verification, because whenever the motor starts, due to high starting current, it gives the voltage drop, and if it is beyond the limit, your system may go shut down. So how we'll do the motor starting study? In the single line diagram, all loads are running, and we will start the motor and check the voltage drop on all our switch gears and the motor. If it is within the limits, then this study is okay. Third is the short circuit study. Short study means the fault current calculation, because as I told you in the MVA current limitation slide, you will check what are the fault current supplied by the transformer in case of fault. So we will simulate the fault in our system, and we will check how much fault is transformer is supplying. If it is in our limits, so we can see, okay, our transformer is okay. So after performing all these study, and all three studies are okay, it is within the limits. So now you can see your transformer is okay, and it is very well within your system. Now we will summarize that what we have seen till now to transformer sizing. So first step always will be to prepare the load list according to the voltage level. What is the voltage level you have selected? You have to prepare the load list, and then do the calculation and select the transformer rating. Decide the cooling type, which cooling type you want to go, ONAN, first to oil type or the dry type, and the oil type, which cooling type you are going to have, like ONAN or ONAF and any other else cooling type. And then decide the tape changer type. You are going with on-load tape changer type or off-load tape changer type. And then you will verify your size on the ETAP software or any other software is available with you. So you will verify, and then you can finalize the size. Now we'll discuss the career path and job opportunities. Electrical design engineers are required in EPC project. EPC means engineering, procurement, construction project, to design the electrical system in all major industries like oil and gas, steel, buildings, fertilizer, data centers, cement, chemical, etc. Like in any industry, you need to have a electrical design engineer to size this all the equipments. Transformer is one of them, like for cables, some switch gears, capacitors, everything. You need a electrical design engineer. And what are the general skills required by the electrical design engineer? First is sizing of electrical equipment like transformer, switch gear, UPS, cable, capacitor, etc. And then you have to perform the power system analysis on the ETAP or any other software. You have to design the layouts for cable trays, earthing, lighting, how we will put the cable tray in the plant, how we will do the lighting in the plant or building, in the mall, anywhere. And the lighting and earthing calculation, how to calculate what are the lighting, how much lighting is required, which light fixture is required, and how to do the earthing, where to provide the earthing. Next is the battery sizing. You have to decide the UPS, how big battery required, what type of battery you need to put, the nickel cadmium or VRLA. So you have to do the battery sizing. The software generally used apart from the ETAP are Dialex. Dialex is very commonly used software for the lighting calculation. SPEL is a power system design, where you can prepare the load list, you can decide the cable, you can prepare the cable schedule. Revit is also one of the software which is generally used in the building sector. So this are the major skill required by the electrical design engineer.